Hi everybody, welcome to the new episode of Tapircast. Today, Dr. Boyacı and I, as Tapircast, will host two distinguished guests from the world's largest technical professional organization for the advancement of technology. This is how it defines itself, namely IEEE. Dr. Hermann Brand, European Standards Affairs Director of IEEE, and Dr. Tuncer Baykaş, IEEE Turkey Section Vice Chair. Welcome to Tapircast, guys.
Good morning.
Thank you very much for having us.
Before we move on, I'd like to kindly ask both of you guys to briefly introduce yourselves for Tapircast audience. Let's start with Dr. Brand.
You already mentioned I'm currently the European Standards Affairs Director of the IEEE. I have another role within IEEE, which is Practice Lead Mobility. In the IEEE Standards Association, we have various practices with practice leads. One energy, one about connectivity, one about foundational technologies. And as already mentioned, I'm the chair of the mobility practice. So this is looking into the digital transformation of transportation and mobility as a service. Before joining IEEE, I worked for the European Telecommunication Standards Institute as Director Innovation and also as Vice President for New Initiatives and Market Development.
Okay, thanks. Professor Baykaş.
Yeah, I am IEEE 802.11 and 802.19 member. I'm affiliated with those standards. I'm a working group vice chair in 802.19, which deals with the coexistence issues between different wireless standards. And in 802.11, I am the vice chair of the Visible Light Communications group. On top of that, in Turkey, I am the IEEE Turkey section vice chair as well. Thank you.
Okay, thanks. Let me just start with the warm-up question, if everybody agrees. By the way, Dr. Boyacı is sometimes, disappearing and appearing. It's because of this virtual background application of Zoom. That's why we apologize for that. Let me just, start with warm-up question. As a person who is heavily involved with standardization efforts, I'd like to start by asking Dr. Brand why standardization is crucial for our modern society. I mean, it's clear that standardization provides some sort of order in society. Without it, there will be definitely chaos. However, what I'd like to dig down and find out is the concealed benefits that are not as conspicuous as order, but extremely important in our modern society. Can we have your thoughts on that?
Yeah, I can give you, of course, I can give you several thoughts about it and also some ideas. But before doing that, I would like to say that the views expressed in this podcast, they are rather my personal views. These are not official statements of the IEEE, so these are not official positions of the IEEE. So let me come back to your question. The benefits of standardization for society and economy. So let's say I want to make this quite simple. And let you think about, we live in complex societies and also in developed or developing economies are more and more technology based. And in such an evolving environment, there are many issues which cannot be solved by a single company, or could also say by a single organization or even country, or by a closed circle of a few companies working together. So that's why open collaboration platforms are needed, and standardization bodies are sort of open collaboration platforms. And these open collaboration platforms, they facilitate the evolution of ecosystems by building trust, by reducing the risk and the costs for individual organizations, by reducing complexity and options also. So this is often a problem for a company to decide where to put the money. And of course, a sort of coordination in the ecosystem helps very much. It also, standardization also ensures a smooth evolution of value networks. So new companies coming in, new divisions of work. It facilitates economies of scale and enables interoperable solutions. There are, what I often say is there are three different drivers for standardization. One is technology. That's already quite obvious. In technology-driven economies and societies. The other is business, and the third dimension is about politics. It's about legislation and regulation on the one hand, but also more loosely speaking, it's about policy objectives and standardization bodies supporting those objectives. I think I'll stop here. There is more to say, but maybe in a discussion in the next step we could touch upon more.
Yeah, definitely, Professor. Let me just hand the word over Professor Baykash, and since he's one of the most active members of IEEE in Turkey in terms of contributing standards, so I want to have his opinions as well. Professor Baykash, what about you? I mean, what do you think of the benefits, concealed benefits of standardization in the society?
I'm going to say, especially for the, from my point of view, I was going to say it's the international collaboration and international work among engineers, at least from our side, is really, really important. So the technology is improving really, really fast, and standardization allows such a collaboration in a global level, which helps the humanity and so on. So that's one of the real benefits to the world. And on top of that, when there is a solution, everyone can benefit from those standards because they are mostly actually shared by the owners with the whole world. So those are the main two things. We work together, and then we enjoy the fruits of this work together as well as a global village.
With your permission, Professor Baykash, I'm gonna steal one of his words, because once upon a time, I think in the previous year, we had his precious ideas in our one of the podcasts, and I asked a similar question, but he answered in an awesome way. He said that during his time, please fix me if I'm wrong, during his PhDs, I think he realized that standards can be basically contributed by anybody, technical people. So as a PhD student, you can also contribute to standardization. So I think one of the aspects of this collaboration, cooperation, and this kind of stuff is I think the openness of this idea to everybody who basically work in the field of this kind of research. So this is my part that I take the lesson from Professor Baykash's PhD. I think this is my humble contribution. So if I proceed, let me just ask.
Excuse me, may I add to this idea?
Sure.
I think this was a very important point you raised, and in IEEE, direct participation in standards-related activities is in our DNA. So it's really about being open and inclusive so that everyone come into a standardization meeting and make a contribution. So it's very important also because our standards are applicable all over the world. So anyone, everywhere, anywhere in the world may implement a standard. And we have also programs where we work with national standards organizations or regional standards organizations to adopt IEEE standards, and even to make specific modifications. We allow some modifications to be made at the national level, because we don't want that other communities reinvent the wheel again and do not benefit from the knowledge already there and codified in IEEE standards.
Yeah, that's an awesome comment, because direct participation, as you suggested, is extremely important. And hopefully in the next episodes, maybe, we're going to have a specific topic for just, direct participation, how we can directly participate, contribute to standardization efforts. We would love to have you if your time permits. So with your permission, I'm going to ask a personal question, because I'm a little bit, curious about that. I want to ask this question because, this is pretty interesting to me. Why does IEEE have an office in Vienna? As far as we can see, IEEE commences several other branches, offices all across the globe in different locations. But what is the benefit here, and why Vienna is one of the branches that, we see? I want to learn that from you, Dr. Brand.
As you know, IEEE is the world's largest engineering society, starting, well, originally electrical and electronic engineers, but meanwhile also including bioengineering and many more other disciplines. So, and I already mentioned, so inclusiveness is in the DNA of IEEE, and we want to facilitate participation all over the world. And that's why IEEE has global offices, what we call global offices, which means regional offices in not only in the USA, but also in China, in Singapore, in India, and now also in Region 8. So we have to keep in mind that the office in Vienna, it's not an Austrian office, it's not a European office, but it's an office for Europe and Middle East and Africa, and even more. It's an office for the Region 8 as defined in IEEE, which also includes Russia. And there are 3 different IEEE sections in Russia. Of course, technologically, a lot of development or a lot of research is going on within the European Union, but we also work with researchers everywhere. And you also asked, let me get back to why Vienna. So there were several reasons why the office was founded in Vienna. One very important reason was Vienna is a melting pot. It has been a melting pot for centuries. So, and it's in the middle of Europe. So from Vienna, you may fly to everywhere in Europe and Near East within 2 hours, a 2 hours flight. So it's and also it's the 3rd city of the United Nations. So you could also look at it as from a cultural point of view. So Vienna, in the middle of Europe, it's culturally speaking, it's a mixture of the East and West and South and North. And this, I could go into details, for example, looking at this statement from a philosophical point of view and compare with Germany, but this is too much for today. And of course, there were some more reasons, like it's a safe country. There is a high level of living. There is research, there is innovation, in particular also in the automotive domain. What is also important, the cost of living is reasonable. It's not as expensive as in Western Europe. But of course, it's a little bit more expensive than in Eastern Europe. But we think it's very important not to be seen as put it the other way around, perhaps. It's very important to reach out to Eastern Europe, to Southeastern Europe, to the Near Eastern countries and the like.
Okay, appreciate for the answer. Let me put it back to the original focus track, if I may proceed. And then, I'm going to ask this question to both of you guys. Let's just, go back to standardization, basically. So I believe these standardization efforts will increase in the near future, especially with 5G right now, what we call 5G or XG, if you want to just, make it variable. It is claimed that everything will be connected. Could you please, guys, elaborate more on this, starting with Dr. Brandt?
Yeah, connectivity. Well, let me give you a broader scope, perhaps. So what we see is that information and communication technologies drive innovations in meanwhile all industry sectors. So we talk about everything smart energy, smart cities, smart factories, industry 4.0 in Europe, not only in Europe, but all over the world. So this is all driven by information and communication technologies. And ICT, information communication technologies, it's all about digitizing, it's all about exchanging information, processing information. So when we talk 5G, this is just the next level of connectivity. And on top of connectivity, of course, why do you connect? It's to share data. So it's about data sharing and actually connecting everything to exchange data. And then the next level is making how to create value from data. And at that level, we talk about machine learning and new technologies, where also IEEE is very much engaged. So 5G is just the connectivity layer. And a lot is going on. The cellular networks, as you know, they are standardized in 3GPP, but IEEE standards and I assume we can get back to that a bit later. So IEEE standards, the 802 family of standards, they are a building block of cellular networks. So actually IEEE, that's at least how I see it, IEEE and 3GPP, these are the two organizations advancing connectivity standards, and in particular radio communication standards, with IEEE being more focused on local area networks and 3GPP more focused on wide area networking.
Thanks. Professor Baykash, I know you're very active in standardization efforts in 5G and XG as well. What do you think about this connectivity layer, connectivity issue for 5G and the standardization efforts for this part of the research? I think you're on. Yeah.
Okay, there are several parts. One, like as a human, actually the limit of data that I can consume is limited. On the other hand, if you think about the number of devices which can communicate is actually increasing exponentially, and we are going to see this exponential increase with the connectivity and revolution. what we will see, and also like all of us actually dealing with the telecommunication here, when you add a device, actually that device will have some beacons, some control channels, and so on. So it is not only the data, but adding a device creates an extra layer in the network, and the networking becomes more and more complex to handle. So with the new standards and so on, actually we can increase the overall efficiency of those systems. On top of that, the spectrum is actually limited. We have seen the results in the 2.4 gigahertz spectrum where the Wi-Fi actually just started. When the Wi-Fi started, the engineers didn't think that that they need to be efficient because the spectrum was empty, and they created a network which has lots of beacons and control signals, etc. And the timing is random, so the total efficiency was low. When the connectivity and the data revolution came, we basically made 2.4 gigahertz an extremely inefficient channel. Now, what we have learned actually is shaping our new 6 gigahertz channels, and in those channels, actually the engineers are handling a much better efficiency to use the spectrum. And when you have strong standards, this efficiency can be increased much more. If you have competing standards in the same channel, the total efficiency drops. So that's why actually standards are important in the coming 5, 10, 20 years, so that we can handle the data requests from all those machines and the connectivity.
Thank you for the comment, and I'm gonna just chip in slightly with your permission, since Dr. Baykash and I work closely on this issue as well. FCC recently announced that I think, you know, terahertz bands are also basically allowed to be accessed by this kind of research. So it's not gonna be just, as you said, some kind of, you know, 60 gigahertz. It's gonna be sub terahertz and terahertz bands as well. And this, I think, creates an interesting problem because the characteristics, radio frequency characteristics, are so different. So it's gonna be a multidisciplinary, I think, standardization efforts, because the materials are gonna be probably different. The surfaces are gonna be smart. I think, you know, we're gonna touch upon that one as well. So my part, I'm a little bit more excited. As you stated, the key term is learned from the original, let's say 2.4 gigahertz band. And I'm a little bit, you know, how do you say, so happy to, you know, have this happening in front of my eyes, because previously 2.4 was set. I was using it, but right now there is a big chance that I think, you know, all of us can contribute to this upcoming era. So again, with your permission, I'm going to ask Dr. Brandt regarding the key point that he raised a moment ago, machine learning and AI. I'd like to touch upon this popular topic, Dr. Brandt. Is it possible to standardize it, and where it goes? Can I have your ideas on that?
Yeah. Let me start by making the statement that AI is not a single technology. It's a whole bunch of different ideas and technologies and methods and techniques, and it's a hot topic because of the computing power we have. And also the availability of data. Professor Baykash, he touched upon this. So the exponential growth of data. So we can create value using data, and and that's why machine learning, and also in particular deep neural networks, are increasingly used for this purpose. In IEEE, you know, as the world's largest engineering society, we not only have technical societies, so our tagline, you mentioned it at the very beginning, advancing technology for humanity. So we, of course, we push technology evolution, in our community, but we also look at the context of how technologies are used. So the ethical dimension, or in more generally speaking, how to build trust in new technologies. And there is the tradition of looking at societal impacts of technologies in one of our societies. And I think IEEE has quite, it's already 4 or 5 years ago when IEEE started to think about the ethical dimension of using AI techniques. And this is very much related also to what I haven't touched upon yet, but it's a sort of second wave of convergence we face. It's about convergence of information and communication technologies with the operation of equipment. So, and of course, if you apply AI, for example, in a car for object recognition and also for decision making and path planning, then there are some safety risks. There, of course, because cars are connected, there are some cybersecurity risks and the like. So that's why IEEE covers not only functional standards for AI, like, for example, federated machine learning or shared machine learning or work on knowledge graphs, but also looks into how to build trust. And there a lot of work is going on in the P7000 series of standards where the hot topics are, for example, algorithmic bias considerations or transparency or explainable AI, and more, of course. So this is just to give you an idea how we see this very broad area holistically.
Okay, thanks. How about you, Dr. Baykash? What do you think about this AI thing, the hype and standardization efforts for, as Dr. Brandt adequately put, I mean, it's a set of technologies, but at the end of the day, everybody talks about AI and its standardization. What do you think of this?
There are multiple attempts for this one, and they are absolutely necessary. But as Dr. Brandt mentioned, actually, one of the important parts is that the ethical parts of the AI use and how it is going to affect the future technologies. We have seen that AI and machine learning, one basic example is that, like, they were trying to reduce the male-female bias in the CVs, and they tried a program and they didn't give the male-female lines and so on, but the AI actually picked up other words and still had that bias of the male and female. So that's why, as Professor Brandt mentioned, like, explainable AI and the standardization of the explainable AI would be really, really important in the future. So we need to look at those, and I'm happy to say IEEE is already working on those projects.
That's awesome to hear. And as I said, people are discussing this AI thing, but right now, as you guys mentioned perfectly, explainable AI is also in the field of research. So it's extremely, it made me, happy. So considering time constraints, with your permission, I'm going to ask the final question. Again, both of you guys. So Dr. Brandt, let me start with you. I'd like to ask your opinions on emerging standards and field of research. What could you tell us about emerging standards and fields of research in the near and the midterm or long run future? Which of them, according to you, would be very active in the short term, so that, for those who listen to this podcast, can be just, shape their future accordingly? Later on, I'm going to ask the same question to Dr. Baykash as well.
I think we live in really interesting times, and never in history so many researchers and scientists have been working to develop, first of all, to discover new natural laws and also to apply them, develop technologies for the benefit of humanity. So coming back to what I already mentioned, so the convergence of information and communication technology and operation of equipment, this results in potentially automating everything. So it's in the future, we do not think about products anymore, but rather services. So for example, it's not so much about a car, but it's rather the mobility. So the purpose, and this, so thinking in terms of what is the purpose of what we know and what are the alternative solutions. So this is a sort of a guideline to think about the future. Technology-wise, of course, everything related to combining the real world and the cyberspace. So the links for doing that is the mixed reality and the cyber-physical systems. But of course, quantum technologies and new platforms for computing. So not the Neumann architectures of computers, but thinking further. So these are the real big challenges. And we mentioned AI already, and of course the scientific basis for advancing the AI techniques. We said this is not a single technology, so there are many new opportunities, and these are based on driving, for example, cognitive science or neuroinformatics and the like.
It's excellent. Thanks, Professor Brandt. How about you, Dr. Baykash? What do you think about the near, short-term, and mid-term, long-run futures?
Well, for the near one, as we mentioned, that the new spectrum bands are coming, the terahertz visible light is already there, and other bands will be worked and so on. One interesting thing which I see more is actually the localization. So for the outside, we have the GPS, but we haven't solved the indoor localization problem yet. So I'm seeing new standardization works even in the 802.11 for the indoor localization and also the sensing applications. Those are the new thing. And other one is actually the using different sensors and making the data collection and also data mining and decision making using the standards. They will be important parts of the daily life. So we are expecting those. We are going to see that how the, for example, the connectivity and the connectivity between the vehicles will change the traffic. Like there are now different works, like they are saying that what if the 25% of the cars are autonomous, what will happen? What if they are 50% so on? And we need to actually check those and create a new world. On top of that, of course, the quantum computer is coming, and then the security will be a huge problem if the quantum computer starts to work really, really efficiently. So we have the physical layer from the telecommunications point of view, physical layer security problems, which we try to actually enhance. So those are the new applications for the standards.
Thanks, Dr. Baykash. And considering the time constraints, with your permission, I'm gonna end this, Tapircast, for today. But before we just closing, let me just, take the word from Professor Brandt. If, in the future, his agenda is applicable, we want to have him one more time to deep down in one of the specific topics that actually, he's contributing to. Is it okay, Dr. Brandt, in the future time, if your agenda allows, can we have you one more time?
Why not? I want to thank you for the invitation. to take part today. And of course, I would be happy also to contribute to another podcast where we, depending on the topic we select, we could have a deep dive. And yeah, greetings to Istanbul and have a great day.
Yeah, thank you. Dr. Baykash, thank you as well. I mean, by just...
Thank you very much.
providing...
And our greetings to Vienna.
Exactly, the same thing. And I want to give a special thank to Dr. Baykash regarding connecting us to Dr. Brandt and making this, podcast happen. I really, appreciate his efforts in both IEEE and for Tapircast. Thank you for providing us with such an informative discussion, guys. Today, Tapircast hosted two distinguished guests who actively contribute to the standardization efforts in IEEE. We'd like to thank all our audience for listening to our Tapircast. Please feel free to send us your questions, comments, recommendations for this episode. All relevant details, resources, and many other extra details could be found below in the description section. And have a nice week. Thanks.